Here's a new video, or the second video, about arrangements, permutations and combinations. And this time we're going to see a few examples and we'll get to know the formulas for permutations and combinations really well. So with permutations, order matters. With combination, order doesn't matter. Okay, so some people say P for permutation, P for pick, C for combination, C for choose. You choose a selection, you choose some things, the order doesn't matter. You pick things in order, first, second, third. Okay, or you choose a combination. That's not necessarily the most helpful thing to remember, but it helps some people. Okay, and we use these special formulas here, which we'll see how they work in a minute. Okay, let's learn this by kind of an inductive method. So if you think about the letters A and B, how many different ways could you arrange them? A, B, and BA. That's 2. How about ABC? Well, there's ABC, BAC, etc., etc. So that's 6. Now, just like here, this was, you can have 2 different letters the first time, but once you've chosen that, there's only 1 that can be second. Here, you've got 3 letters that can be the first one, which leaves you with 2 that can be the second one, and 1 that's the third. So it's 3 factorial, which is 6. How about letters A, B, C, D? Well, there's all the combinations, the 24, but again, it's 4 times 3 times 2 times 1, 4 factorial. How about A, B, C, D, E? 5 factorial, 120. So that's your arrangements. Okay, factorials. Now, how many different one-letter permutations can you get from here? Well, again, you can get A, B, C, or D, so that's 4. How about 2-letter permutations? So that's A, B, and BA. And by permutations, we mean the order is important. So A, B, and BA are different. Okay, so A, B. So there's 3 that start with A, 3 that start with B, 3 that start with C, 3 that start with D. Okay, and then for each of them there's 3 that are the other ones, so that's 12. And also, how many different letter combination permutations can you make of this? And again, it's all them, so that's 24. It's got to be an easier way to do this. That's with this formula. N permutation R is n factorial divided by n minus r factorial. So n is how many things you have. So here we have 4 letters, and I choose 1. R is how many you choose. So it's 4p1, which is 4 factorial divided by 3 factorial. So basically you just cancel that lot out, and you get 4. Okay, so this would be, you have 4 letters, you're choosing 2 of them, so it's 4 permutation 2, 4p2, 12. As you cross out those 2, and you get 4 times 3. And again here, it's 4 combination 3. 4 combination 3. 3 is 4 factorial divided by 4 minus 3 is 1 factorial. There we go. 24. So what about this? 4 from 4. Well, that's also 24. And this is a special case because 4 minus 4 is 0. 0 factorial is defined as 1. So that's kind of something you're going to remember, or something that might trip you up. But 4 factorial equals, 0 factorial equals 1. Okay, let's talk about combinations now. So this time order is important. So ABCD is just ABCD. But this time AB and BA are the same thing, so you don't have to count it twice. So instead of 12 different ways of doing this, there's only 6. Instead of 24 different ways of doing this, there's only 4. Right? Because ABC is the same as BAC, is the same as CAB. So there's like 6 different ways A, B, and C can be together. So that factors down to 4. Same here. How many 4-letter combinations can you make with this? Well, ABCD. And BACD D, A, C, B, it's all the same. So there's only one there. Okay, and so this has the formula NCR. All right, but you'll often see it just written like this in a sort of a vector looking thing. NR, N combination R. So this just means N combination R. And here's a slightly different formula. You got to divide it by R factorial as well. So it's the permutation formula over here. N factorial divided by N minus R factorial, but also divided by R factorial. So in this one, you got 4 combination 1, which is 4. Here we've got 4 combination 2. Here we've got 4 combination 3 and 4 combination 4. Okay, have a little study of that and see how you can cancel things out, and writing it out like this might take a bit of time, but it means you don't need a calculator. It's so easy. Okay, of course you can do this NCR on your calculator, and yeah, it's only pressing 4 buttons and you're done. So you can decide that too. All right. Rather than using a formula or using a calculator, we can actually use this thing called Pascal's Triangle. If you're not familiar with this, might be do a little research, but you can see the numbers here come from adding the 2 above. So 1 plus 1 gives you 2. 1 plus 2 gives you 3. 3 plus 3 gives you 6. 3 plus 1 gives you 4. 10 plus 10 is 15. 35 and 21 is 56. All right, so the 2 numbers above tell you what numbers come next. And this is useful for a whole lot of things. I've got another video on this somewhere. I'll link below. But yeah, use this. This tells you the combinations. Let me show you. Here, 4 combination 2 we know is 6. But this is the 4th line. Let's ignore this one at the top. But 1, 2, 3, 4. And then 0, 1, 2. 4th line, count 0, 1, 2. You get 4 combination 2. 6 combination 4. You go to the 6th line with the 6 in it, and you count 4. 0, 1, 2, 3, 4. One more. 8 combination 3, so go down the 8th line. 0, 1, 2, 3. You've got that there. Okay, so Pascal's Triangle will help you very much with doing this. So if you have it handy, it can help you do this without a calculator. Okay. I wanted to show you 2 examples of special cases, but here's the little summary of what we've learnt so far. If you're picking from a big group and order matters, then you use permutations. If you're choosing from a big group and order doesn't matter, using combinations. Pause the video and have a look at these 2 and see if you can understand these 2 examples. Okay, you can see that here, 1, 2, 3, the order is important. Okay, 3 people here, 3 people committee, order is not important. So there are many more ways to do this because your 3 people have specific roles. If your 3 people don't have specific roles, there's less ways to do it. Okay, here are some special cases. How many ways can you line up 6 people? Well, we did that before. 6 times 5 times 3, 4 times 3 times 2 times 1, 6 factorial, 720. How many ways can they go in a circle? Well, where does the circle start and finish? Don't know. Okay, so you start somewhere, and here I start with B. So I start somewhere with B, and then what comes next? Well, lots of different things. So because I don't have a defined starting point, but I do have 6, I ignore the 6, right? Because there are 6 different ways. Over here on the left-hand side in the line, there are 6 ways you could start the line. But here we don't have a start. So we kind of ignore the 6 and just say there's 5 factorial ways you can line them up or circle them up. The other special case is when you've got extra arrangements here. Okay, so we've got 4 women and 5 men. They've got to sit them in a row, but the women have to go on the even places. So place 2, 4, 6, and 8. So how many ways can we put 4 women in 4 seats? That's 4 factorial. And then we've got 5 men in 5 seats. That's 5 factorial. So it's 4 factorial and 5 factorial. So when we say and in probability calculations, we multiply. So there are 22,880 ways to do this. Last special case is, okay, you've got a drama team putting on a play. There's 3 characters. There's different props you have, and you want to make different costumes. So you've got 3 characters and 4 coats. How many ways could you arrange that? 4 permutation 3. How many ways could you organize the waistcoats? 5 permutation 3. And order is important because they're 3 different characters. And 6 permutation 3 for the caps. So how many different ways could you do it all together? Well, it's this and this and this. So when you say and, you multiply. So even with only, 15 different pieces of costume, you can get an amazing variety of costumes. All right. Hope this was helpful and hope this makes sense to you. I know that's a lot of information in a short time, but I hope this was helpful. Good luck.